people asking me questions. I draw all things here. Part of the things is about signals. Okay. So what is the meaning of signals? Signals is actually a very broad topic. Okay. I only select a part of it. So why is it so broad? Let's take a look. Actually, we have different types of signal. The number one type, I give numbers here. Number one, number two, number three. The number one type is from the hardware. Okay, so hardware actually will generate signals. Let's say segmentation faults. Segmentation fault is actually a signal directly returned from the CPU. The CPU finds something wrong. Let's say that you can try doing division by zero, having an equation 1 divided by 0. Then you will immediately receive segmentation fault, or some system will say that floating point exception. Some system even don't understand what is going on. Let's say you can try in your Visual Studio. Visual Studio will boom, showing you a big red cross there and tell you that there's a bug in the program, okay, but never address what is the bug, okay. This is a direct signal from CPU. Some is a hardware signal, okay, but hardware signal we don't discuss, okay. We just discuss a subset of it. Type 2. Type 2 is generated by the kernel. The kernel code itself generates the signal. One of the examples we already understand is the SIG child. The SIG child is actually generated from the code of the exit. Your core exit go into the kernel level, and let's say this guy is a kernel code, will generate SIG child. Third type is from process to another process. So that means the communication between two processes. We can send signal from one process to another. Okay? So these are the three types. How many types you can control? First, you can write a program to generate segmentation faults. But actually you cannot say that, yeah, I want CPU to fire that signal just for that moment of time. You cannot do it. Okay? Can you say, let's say tell the kernel that, yeah, generate periodic SIG child for me? You cannot. But process to process type 3 signal, you can always generate it based on your need. You can generate this is a joke, okay? You can generate a control C signal periodically to every process in your system. Yeah, you can do it. Okay, just write a for loop. Okay, for loop for every PID. Okay, send a control C signal there, and then boom, you kill the entire system. Okay, yeah, it is doable. Okay, no problem as long as the process belongs to you. Okay, remember, it belongs to you means that you create that process. You cannot kill your, let's say you go to a department machine, there are many users, and then you launch a for loop, kill all of them. No, you cannot kill other people's process. Okay. So this is allowed, and we will focus on type 3. So just give you some very brief introduction on what is hardware signal. Okay, and why we need it, because it's kind of related to the previous talk over the signal handler installation on the SIG child signal. Okay, so this is the diagram you've seen before. Okay, the it's the CPU. Okay, the CPU is running on a user level process. Okay, now what happened next? What happened next is there is we call it an interrupt. Okay, interrupt is a noun. Okay, the interrupt interrupts CPU. Okay, this noun, and there's a verb. Okay, there's a guy called interrupt who interrupts the execution of CPU. So what does it mean of interrupt? Interrupt is, there's some wire connecting to the motherboard, okay? And I don't care whether you're using USB or other connection type. Eventually, this device needs to tell the CPU that, hey, I received something. Do you want to handle it? Okay? It's an invitation basis, okay? I ask you, hey, do you want to handle it? And CPU has to decide whether this keyboard interrupt, should I handle it or not? By what? By an array. Okay? There is an array hiding inside the CPU. We call it interrupt vector. Okay? And array index, array has an index, okay? From 0 to n-1, right? How many of you have heard of this three character characters. How many of you have seen this 3 characters before? No one. Okay. So, time for Google. You know, Google is your friend. IRQ. Okay? Yeah, it's already tell you what is IRQ, huh? The IRQ is a number, I would say. A number, hardware lines, okay, whatever things, okay, is to send something to your CPU. It's kind of a high level description. I give you something even more high level, okay? Actually, the array index here is associated with every devices in your machines. Let's say, I can remember, it says IRQ1 is a clock or keyboard. IRQ number. I spelled wrong. Numbers. What are IRQ numbers? Okay, let me see. I can't remember what it says. I remember network cards number 9, something like that. Oh yeah, here it is. The array index 0 is the clock. 1 is the keyboard. Is it 9? Is it network card? 9? Oh no. ICPI. And what is the network card? 11? Open for maybe 11. Okay. Yeah, there are some array index. You can create an array index, huh? 0 port. I don't know whether you have heard of something called sign cap. Okay. How many of you have seen real sign cap? No one. Okay. Let me show one of my friends. I don't know what happened to my friends. Okay. He find a nice bunch of things. Oh, MTL stuck again. Oh, no. This guy. Okay. Yeah, he finds something interesting. I don't know where did he find it. Okay. So this is modem. This is a modem card. This is a SCSI card. This is a TV tuner card. When you plug into your computer, you can let the computer to watch TV program. Okay. Of course, you have to insert the antenna here. Okay. Some hardware acceleration card. Hardware acceleration. There. This is the sound buster. This is the sound card. Okay. Suppose that there will be some. Oh no, this is not sound card. What is that? Buster Banshee. No. Where is sound card? Oh, yep. 100 megahertz Pentium. Okay. No sound card. Oh, sorry. Just imagine that this is sound card. Okay. If it's sound card, there's some holes for you to plug the wire in, right? But it's no. Okay. Maybe put a wrong name here. 3D Banshee. No, it's that. Okay. So you insert that. Then when you insert the card in a motherboard, you will do the following. What should you do? Insert the card. Then you will use the CD or floppy drive come with the hardware to install the driver. How many of you have experience in installing driver? Usually no, okay? Because nowadays when you insert a new hardware, the computer will go online, go to Microsoft server and download the driver for you. During my time, it's not the same thing. Okay, we have to install the driver from a CD. Actually, what is a driver? Driver is code inside kernel. When you install a driver, you actually put the driver code inside the kernel. That's why there is a function inside the kernel. I draw this little box here. It's actually the function inside the kernel for your install driver. Okay? And that means that the hardware installation process is so dangerous. You are putting code inside the kernel, and what if those code is not well written? Then segmentation faults. Then you will have root of that. Okay? So you are installing driver codes here, and at the same time, the hardware side will know that, okay, I now know how to process your hardware and give you an IRQ, the number. That means allocating an array index for your hardware just installed, and what this array is pointing to is actually an address pointing to the function that you install inside the kernel. So this is the mechanism of installing driver. Okay, and instead driver cooperating with the hardware itself, hardware plug in, registered a number inside the CPU, and the number eventually guides you to the kernel. So whenever you hit the keyboard, actually you are calling kernel for help to get the number, maybe a key from your keyboard, put it here. Okay, and when you type, the CPU immediately call this, we call it a interrupt handling routine. Okay, maybe this is something that you have heard of in some low-level hardware courses. Interrupt handling routine. So what is interrupt handling routine? It's actually a code inside the kernel. CPU receive it and call this. Yeah, there's a guy very annoying, keep typing me. Okay, you handle it. I don't know how to handle. Okay. Yeah, usually the story is like that. Okay. Now let me connect the story with this big diagram. So how can we connect the entire story? The story is like that. Let's say you call scanf. Okay, let's get it. Call scanf. So the scanf first is actually calling what we call the read system call. Okay, and the read system call is a new system call to you. Okay, meaning that it will read a device or read a file. Now, when you read the device, when you find that the device that is associated is the keyboard, right? Scanf is read the keyboard, but the keyboard, no one is hitting it. So you will be waiting inside the kernel, waiting. While you're waiting, then how about you type something? When you type something, the signal go into the hardware receive it, tell the CPU, hey, there is a naughty guy just hit the keyboard. I don't know how to handle it. Okay? CPU will tell you, kernel, handle it. I don't know how. Okay? So the keyboard interrupt handling routine will be called. Okay? Will be called for what? For actually copying that number that you just hit. Okay? Every keyboard key has a number. Okay? Copy that number, translate it into ASCII code, and bring that ASCII code to the process who is waiting for your service and return. Okay, so this is the thing. Okay, and the thing is just like this. We call it asynchronous. What does it mean asynchronous? It doesn't mean that this guy will keep monitoring the keyboard. No, they are separated. Okay, and by the meaning of they are separated, you can look at it from the CPU point of view. The CPU point of view is like this. Let's say this is the scanf program. The scanf program called the read system call, and look into the kernel buffer. The kernel buffer say that no, I don't have any key reserved for you. Okay, you wait. So you will wait. Okay, so this moment is a waiting moment. Now this is a new concept which will be discussed very deep in the next part. But before we go to the next part, let's take this for granted. When this guy is waiting, we shouldn't let the CPU idle, right? CPU is a very important resource. I give you power, you should work, okay? Then what should you do? The kernel knows that this guy is waiting, so it's time for me to pick another guy to run, okay? So this is a new concept. And I call it rescheduling or schedule for another process, okay? So the kernel now, at this moment of time, schedule another process. And now another process is running. And maybe another process is doing some system call, no problem. When you do system call, it won't mean that, I should give the touch back to this guy, no. Okay? You call system call, it's your problem, okay? So you call system call and go back, okay? Maybe you call many times, no problem. And then you'll continue to execute until when? Until someone hit the keyboard. Now, this is what we call asynchronous. Asynchronous means that this guy waiting, the CPU won't wait together with this guy. The CPU don't care about your status. I will serve another guy. For the entire system, that means that actually we have certain things going in parallel. One parallel guy is waiting. One parallel guy is running. Another parallel guy is the interrupt, can come at any moment of time. Okay? Now, let's say the parallel events come. While I'm executing some code with this light green guy, interrupt comes in. Now when interrupt comes in, so what should you do? You will let the CPU to execute the interrupt handling routine. So you will enter the kernel code again, or don't call it interrupt handling routine, call it driver. Okay, I call it a hardware driver. Okay, hardware driver for the keyboard. So you do something over the keyboard kernel driver, and after the driver finish, maybe it is time for me to deliver the data. So what's the data? The data that this guy is waiting. Okay, so this guy's waiting for data. So you deliver it through the code of the kernel, copy the things into the memory inside the process, and let that guy continue to execute. So sorry, this guy, I only have one CPU. I cannot let every guy to run in parallel. So this guy run, this guy will be suspended because I hit the keyboard. Okay, so this is the flow. Okay, actually this flow is not easy to understand. Okay, if you have any problem, just interrupt me, or you think of some other things you want to ask, just interrupt me. Okay, I have interrupt handling routine here. Okay. So this is the hardware things. Now how about software things? Software things is very similar. Very similar in the sense that we don't have a hardware things. We don't ask the CPU to install a hardware interrupt handling routine or driver, okay? But we have a standard. The standard, we call it POSIX. POSIX comes together, the operating system standard. We call all the signal POSIX signal. It's a process-to-process talking mechanism, or one of the mechanisms. There's many mechanisms to talk between processes, okay? And you already seen this a lot of time. Control C, Control Z. Oh, I show you Control Z, right? Control Z is suspension signal. This is termination signal. And there is one more termination signal, Control /. You can try it. Yeah, let's say that I write a program, while one. Okay, let me clean the screen. Test. Then actually I don't need it. While one, okay. What? Yeah, I'm in the wrong directory. Sorry. Yeah, I should hide it. Hide the directory palm. Okay, I hide it. Then I don't know where I am. Okay, examples. Okay, for free. Okay, let's write another program. Make it short. While one. Good. Okay, run it. Okay, so you know Control C is to kill it, right? Another is a Control /. Control /. And also say quit. Okay. Control Z, suspension. Okay. Now how to bring it back to life, I will tell you, but the command is FG. Then we will send what we call a continuation signal, okay, and a termination signal. Okay. So you can go through this command to send signal. Another way is to use the Q command. Okay, I don't know whether you have tried the Q command or not. So let's continue with my program here. I edited it so that you will see its PID. printf %d. Yeah, I'm lazy. Yeah, put everything in one line. Compile. Yeah. Cannot be lazy. I hate to see all the warnings here. Okay, so it's running. So this is 4152. Okay. So what is the meaning of Q? Q is a mechanism to send signal. So 4152. By default, it will send a signal called termination signal. Then it will say terminated. Okay. Actually, we can change. We can change to other signal. You can send a signal segmentation fault. Then it will, oh sorry, wrong PID. Okay. Then it will say segmentation fault. Yeah, the segmentation fault is a signal. Or you can try one more. How about the previous control backslash, right? It said quit, right? Then you say quit, send a quit signal. Then you say quit. Okay? So you can change the signal that sends to this guy. And also this guy can also adopt a new handling routine. Okay? This means that if you give me segmentation for signal, I die. Actually, I can do something else. Okay? So this is also the mechanism for hardware, right? Hardware, you install the driver. Now I actually can change. By the way, let me finish this. How about another way? It's a system call. We have a queue system call. The queue system call allows you to write a program to send signal. Okay? Remember, this is a very common mistake. People always think that queue is to queue. No, queue is to send signal. You can select which signal to send. Okay, I can say it's a child, okay, but it doesn't make sense. Okay, so let's take a look at this pair. You have seen this, right? And remember my conclusion. My conclusion is, what is that? The default, actually, I would take it for granted, so I have to mention this now, okay, before you get lost, okay, when I say too fast. When I say I want to kill something, okay, I want to kill something, actually, I don't mean I want to kill something, but I want to send something a signal. Okay, let's say I want to send 1, 2, 3, 4 process a signal, and so happen that this guy, terminal B, is running this program, and I'm sending 1, 2, 3, 4, 1, 2, 3, 4. So happen to be this guy. This guy, the default signal handling routine here, or signal handler, is termination. It so happened like that. This combination together kill this guy. What happened if I change this command? This command, the default signal, we call it sig term. I change it just like I do it in a terminal. I change it into a segmentation for signal. Okay? Then this guy will receive segmentation for signal, and it so happened that the default signal handler for segmentation for signal is termination. Then this guy terminates. Now, that means that everything has a default. I can change the default and let you to see what are the signals that we can play. First of all, we have a bunch of signals that we can play. They are some names. Why we call this like so strange? Huh? Let me show you this. Okay. What is that? Main signal. Okay. Let's read the main page of signal. Okay. So the main page of signal, when we scroll down. Yeah. Here. Actually, I'm reading all the names for a C program. Okay, so this is the name for C program. There are so many signals here. Okay, so how to read those signals? First of all, this is the programming name. Okay, and actually this is a defined constant. So 2 means sig in, and what is sig in? Interrupt from keyboard. And what is the meaning of interrupt from keyboard? Control C. Or another one, segmentation faults. Segmentation fault is a defined constant, and so happen that this constant equal to 11. Okay, this constant is 11, and it means invalid memory reference. Okay. Now, what is the column here? The column here is term, core, ignore, continue. So what's core and term? Can I find it out here? Core and term. Here. Term. Default signal handling routine or default action is terminated process. So what is IGN? IGN is ignore. Default action is ignore. So what is the signal that is a default by default is ignore? Let's check. IGN. I know. What is that? Sig child. By default, it's ignore. It's don't care about the sig child unless you call wait system call. Okay, it will handle it. How about this guy? CONT. CONT. Now let's go here. Default action is to continue the process. Okay? So I can do the following. If you understand this, then we can play this straight. This is the program. Okay? First of all, you can do the following to kill it, no problem. This is the control C signal. Now how about I change it? I change to another signal. Oh, sorry. Another signal is, I want to try the stop signal. So what is a stop signal? Default action is to stop the process. Who are they? Who are they? Can you find any stop there? No? These two guys. Okay? We can stop it. Okay? When it's stop process, when it's stop titled at terminal. So this is, you should not use it. This is for debugger. The debugger will use it. This is for normal user to use it. So that means I will use this name, TSTP. Okay, so this guy is running. So I will send a signal Q TSTP for one. Okay, stop. Now, the reverse of it, continuation signal. Okay? I can send a continuation signal to this guy. It seems nothing, right? Nothing happened. Let's take a look at top. Yeah, this guy is spinning. It's running again. Okay? Now I can try again. If I call stop, you will see the text will disappear. Now I press enter. Yeah, wait for some time. Disappear, right? Continue. Yeah, appear again. Okay? So this is the control of stop and continuation. Of course I can terminate him. I don't like him. I don't like him. Kill. So what is the Q signal? Q signal is very horrible. This guy. It's called Q signal. Okay? Q signal, I read kernel code. Okay? I read kernel code is, if it is a Q signal, then it is a must die signal. No one can stop. Okay? So of course you don't want to be so arrogant. Okay? I choose a more gentle signal term. Okay? The default termination signal when you use the Q command. Q. Then this guy gone. Okay? Now after I kill it, can I send continuation signal? Yeah, bring back to life. Okay? No, of course. Because I already killed it. Okay? If you cannot bring back to life and say, hey, continue to run. No, it's already gone. I remember. Just like calling exit. Okay? So those are the demonstration of this bunch of signals. The in, the term, both are for termination. This guy is generated by Control C. This guy is the default signal of kill. Top, the stop. Sorry, not top. Stop. Okay. The stop, and its reverse continuation signal. Sig child. No need to send a sig child, right? Sig Q is a must die signal. Now, before we stop this lecture, we will try. I will skip ahead, okay? Let's try this program first, and then we will go back in the next lecture. So what this program is doing, can you guess? Can you guess what this program is doing? First of all, what is Q? What is Q? Q is a system call. Okay? The system call, the first input is the PID, the target that you want to send the signal to, and the signal. Okay? So this is a termination signal. And who is the target? Who is the target? What is the way of get PID? Yeah, I know it's PID, but who? Whom PID? your PID. Yeah, you can do this. Okay, you can do a suicide. Okay, you can send a signal to yourself and kill yourself. No problem. Okay, it's allowed in Linux. Okay, but it's not allowed in real life. Huh? Okay, so what this program is doing is just I play a game. Okay, just like you have a die. Okay, you have a die. You throw for 3 times. Okay, and if the die is thrown for 3 times or 6. Okay, then you kill yourself. Okay. Now let's try for how many times it will be able to kill yourself. So let's take a look at this suicide. I didn't make, sorry. The suicide program. Okay. So this is the program, and I also count how many times. Okay. I just count here. Count for how many times before you will send the suicide signal. Okay. 66. Okay. Reverse 60 trials. I don't know whether it's statistically okay, but yeah, it's just a game. Okay. And then you kill yourself. Now this is not something interesting, right? It's just I know we can use command. You can use terminal. You can write a program to kill yourself or kill others people. Okay. Actually, you can do the following. I don't know what will happen, so that's why I won't run this program. But you can definitely try this. Okay. Guess what will happen? Int I for I equal to 1, I smaller than equal to, let's say, this number, I plus plus. What will happen? Yeah. I don't know, okay? You try. Yeah, you try. What will happen? Yeah, maybe this is not interesting enough. You send a segmentation fault signal to every processor, maybe belong to you. If the process belong to you, that's okay. If the process don't belong to you, then Q will fail. Okay? So I don't dare to run it. Okay? Before I end this lecture, I will try to run it. Okay? Yeah. First, let's compile it. Eh? Yeah. Sorry, I forgot include the signal.h. Okay. Okay. Of course, this program is not dangerous enough. If I not equal to get PID. Sorry, my fault. That is more powerful, right? You agree? I don't know what will happen. Okay, I will run it before I end the lecture. Don't worry. Okay, so let's take a look if I want to handle a signal, how to write a program to handle a signal. Okay, so handle a signal is very easy, very, very easy. You just write a program. Before you want to turn on the handling, you call this system call. We call it signal system call. Signal system call, you insert the number that we want to handle. Let's say you want to handle in. Let's say you don't want to have Control C to kill you. Okay? Write down the Control C signal number. Let's say it is int. The handler that you want to insert. You can insert a new handler called ignore handler. You just write sig_ign. Then Control C will be ignored. Okay? So you can write this program. Oh, where's my terminal? Okay, so you can write this program. And actually, I have a program here already. Okay? So I can write this chill signal. But what is this input? This input is a function name. You have to supply the function name so that the kernel know what is the signal handler you want to install. Actually, it's just like a handler installation, like a driver. You say that when you see this hardware signal, call this driver. Now you see this software signal. This is a software signal. You handle it using that function. The function is called sig handler. with the input parameter an integer, okay? And an integer, it so happens to be the signal you receive, okay? So in my program, I will say I receive something, okay? It's totally based on the input to that function. And the function, you should quit it. You cannot say that, when I receive a function, I do a while one loop. Oh, no, don't do this, okay? So let's take a look at this program. This program, what it's doing, it will register the two handler called getChar, okay? Normally, getChar will read one character and return, okay? It's a handle in, okay? So if I press enter, it will receive enter. So %C, the character will jump to the next line, okay? Let's say I type hello, then it will receive H because I want one character only. Now this is the normal behavior. Abnormal behavior, Control C. Can I terminate the program? No. I cannot terminate anymore. Okay. One more is the SIG_quit. SIG_quit is generated by Control /. I cannot kill it. Okay. Yeah. Imagine that you write a program that cannot kill by Control C is horrible. Okay. Very horrible. Okay. So how can I quit it? Enter. Okay. So what is the meaning of pressing enter and I can quit the program? Yeah. Sorry. C. Okay. It means actually this getChar is running, waiting for your input, but I receive something, which is a signal. Then you will jump to the handler, and then come back and still executing getChar. Whenever you receive another signal, go to the handler, and then come back. Handler, come back, handler, come back, until you give something valid. Let's say the enter. Then finish the program. Okay? So this is the handler. And next time I will tell you more ways to handle signal. Of course, I know you